Hello, grade 10s, a warm welcome. This is another Junior Taki production. I'm your host, Mr. T, and I'm excited to be presenting to you another lesson under the series on functions. In this specific video, we're going to be looking at interpretive questions, starting with the one below. The graph of f of x is equals to ax squared plus q is sketched below. Points A and B lie on the graph of f. Points A and C are x-intercepts of f. Let's look at the first question. 7.1 reads as follows. Write down the coordinates of C. If a question comes and says write down, and it's a one-mark question, there is no need for you to show any working. You just write down the answer. But just to give a bit of theory and understanding for those of you that might struggle, I'll start by drawing the axis of symmetry of that graph, which we know that at grade 10 it's always x is equals to 0. If you apply your analytical skills there, you know that the distance from the origin to A is equivalent to the distance from the origin to C. In other words, A is a reflection of C or vice versa. That means they have the same distance from the origin of 2 units. So the coordinates of C becomes negative 2:0. We move on to 7.2. 7.2, we are required to determine the equation of f. So we're going to start off by identifying that function. The general equation f of x is equal to ax squared plus q is a general equation for a parabola. So we know we're dealing with a parabola. So I'm going to start off by writing that general function. But what are we going to do with that general function? We go back to the diagram. We want to make use of the given information. We know we've got point A and point B respectively. So I'm going to substitute the point A for starters. So I'm going to substitute the point A with coordinates 2:0, forming the first equation of 0 is equals to 4A plus Q. That's my first equation. I'll do the same thing with the second equation of second point of negative 3 is to 2,5 to form my second equation of 2,5 is equals to 9A plus Q. That's my second equation. You should already see where we are taking this to. We're going to solve them simultaneously through saying the second equation minus the first, giving us 2,5 is equals to 5a. Calculating the value of a, our a value is a positive half, which is consistent with what I'm seeing on the diagram. We expected the value of a to be positive. Why? Because the graph is concave up. Now, even before we calculate the value of our q, we should know that the value of q must be a negative. Why? Because the turning point lies below the x-axis. But let's prove it. So I'm going to calculate the value of q through using equation number 1. Another would have chosen to use equation number 2. It does work as well. So I'm opting for equation number 1, which is your 0 is equals to 4a plus q. I'm going to substitute the value of a, the calculated value of a of a half, into that equation. We get a is equals to 4 times half plus q. We get our q value to be negative 2. And therefore, we can make a conclusion that our equation is f of x is equals to half x squared minus 2. We move on to 7.3, the next question. In 7.3, they say write down the range of f. Again, it's saying write down. To determine the range of any parabola, our focal point is always our q value. So it's either it would be greater than or equal to our q value or less than or equal to our q value, depending on our a value. Because our a value is a positive, we know that we're going to have a range of y greater or equal to our q value. Therefore, just to write it down, we're going to say our range will be equal to, greater or equal to negative 2, or written as y an element of minus 2 up to infinity. Up to infinity and not 0. Up to infinity and not 0. I'm just going to correct that. Up to infinity and not 0. All right. We move on to 7.4. For 7.4, they say write down the range of h, where h of x is equal to minus f of x minus 2. you should recognize that h of x has been transformed. There's a double transformation that has taken place. The first one would be a reflection in the x-axis followed by a shift of 2 units down. But let's just illustrate that to give a bit of context. We know that the lowest value is minus 2. So a minus f of x, theoretically, it is a reflection of the graph of f of x in the x-axis. To illustrate that, what am I saying? It means I have reflected that original graph about the x-axis, and immediately I've shifted the same graph, the orange graph, I've shifted it 2 units down to give rise to the final graph, which is the green graph. So h of x is actually that green graph that you're seeing. So that's your h of x, the green graph. So now, what is the range of that graph? The range of that graph, I think now you can see it clearly, that it is y is less than or equal to 0. Y is less than or equal to 0. Very much straightforward. Or you could write it as y an element of minus infinity up to 0 included. We move on to the last question. Question number 7.5. Determine the equation of an exponential function g of x is equal to b to the power x plus q with the range y is greater than negative 4, and which passes through the point A. Very important. The range is given. That range is associated with our q value. So in other words, we already know our q value based on that range. So to kickstart, I'm going to write g of x is equals to b to the power x minus 4. Where did I get the minus 4 from? The range. Now I'm going to substitute the point A, which is given by 2 is to 0. And if I do that, I'm going to get the equation 0 is equals to b squared minus 4. Solving for b, we get b squared is equals to 4. And I get my b value has to be a positive 2 and not negative. And therefore, the conclusion is that g of x is equals to 2 to the power x minus 4. I hope you enjoyed that lesson. Keep watching, keep subscribing. Until next time, bye-bye.